Okay, we're going to look at a problem in the book. It was for homework, and it talked about impedance. Let's go ahead and see if we could find the problem here. Here we are. Here's the problem. Impedance. The opposition to a current in an electrical circuit is called impedance. The impedance Z in a parallel circuit with the two pathways satisfies the equation as given. And it gives Z1 is the impedance in ohms of pathway 1 and Z2 is the impedance in pathway 2. So we find the impedance of each pathway in a parallel circuit by adding the impedance of all components in the pathway. Use the table to find Z1 and Z2 and then find the impedance Z. So what we're looking at is, first of all, we have the equation for the impedance, and then we notice that in pathway 1, this symbol here is your voltage source. And when we look at the path for 1, we have this device here, which is an inductor, and that gives us the impedance of 16 ohms. And 9 ohms is the impedance for the resistor. Now, look at it, circuit 1. What we have to look at now is it's the pathway 1 is Z1. So Z1 is equal to, from the table, the inductor is BI, and it is B ohms. So we read it, and this says 16 ohms, so that would be writing 16I. And then the resistor, we see the resistor is just the real component of a complex, and that would just be A ohms, and so this would be the real component would be 9. So when we look at summing this this circle, call it loop, we would have Z1 is equal to 9 plus 16I. So finally, when we analyze what Z2 is, we look at path 2. Path 2 again, as your voltage source comes around, has your resistor, has a capacitor with an impedance of 10 ohms. The resistor had 20 ohms as listed, and then it goes back to the voltage source. So Z2 now is equal to, now remember, the impedance for a capacitor is opposite, so it's opposite CI. So what you'll find is that this will give us here a 20 is a real, and this is a negative 10I. So Z2 is going to be 20 minus 10I. So what we're solving for is Z. So let's set up our equation now. Now that we know that 1 over Z is equal to 1 over 9 plus 16I plus, and then we have 1 over 20 minus 10I. Okay, so that's our setup. So now what we have to do is we have to solve that. Now, like anything else, what we have to do is kind of fiddle around with this a little bit, and let's just concentrate on the right side. Now, we could talk about, yes, these are fractions, and yes, we would need common denominators, but let's not jump into the common denominator right away. Let's go ahead and multiply by our complex conjugate. So we'll just carry and leave the 1 over z on the left side, and let's write this 9 minus 16i here. Remember, we're multiplying by 9 minus 16i over 9 minus 16i. And when we do this, we will find that this will be 81. Okay, and remember, 16i times 16i, a negative 16i, is going to be a negative 16i squared, or a plus 256. And then we go to this one here, we go 20 plus 10i, and that's going to be over 400. And again, remember, we have a minus here, and when we do the complex conjugate, we're going to get a plus 100. Okay, you should be able to do those on the side doing your practice. Okay, so I'm doing this problem not just to show all the complex conjugate work. You should be able to go through these because in your previous work you know the squares of all these numbers, so it should be insignificant. Now, now we're going to get into our common denominator work. So let's just go ahead and combine our like terms. And we notice that in my work zone here, I'm going to put 256 plus 81, and that's 7, and that's 3, and that's 337. 337 plus 20 plus 10i over 500. So what we finally get then is, to get a common denominator, we would write 500 times 9 minus 16i plus 337 times 20 plus 10i all over 337 times 500. And that's 1 over z. So we could now look at what z is, and we could just say z is equal to, I think we'll go ahead and leave the 337 and leave the 500, and we would put this then, we have to do some work now because we're going to have to simplify this. And notice when we simplify it, it's going to end up where we're going to have to rationalize the denominator again relative to the complex number. So let's just start plugging away here at our work zone. So I'm going to go ahead and take 500 times 9, which is 4,500, and that's a positive. I'm going to combine it with the real part here, and I'm going to take 337 times 20, and that's 6740. So I'm going to add those together, and I know I'm taking the time here just to just show you that it's just meticulous. It's not hard. So the two real components come together to be 1,000 or 11,240. And let's go ahead now and work on our reals. So 16 times 5 is 8 times 10, or 80 with two zeros. So that's 8,000 is what 16 times 500 is. And then I see I have 3370. And notice this is a negative 8,000. And then this is a positive 3370. So I'll go ahead and do that math. And I get a negative 4630 minus 4630i. Okay, so our last step now would be to multiply by the complex conjugate. So it would be 11,240 plus 4630i over 11,240 plus 4630i. And we notice that when we complete that work, we will now have an answer of 337 times 500 times 11,240 plus 4630i. And careful here, let me just make a little note. We have a break in the vinculums, okay, the fraction bars. But we really would be good to group this when we write that. So there's no confusion when we write and script our math, because I've got a little bad math there because I didn't group it and I look like it might be one vinculum. There's a minor minuscule break there that I left. But let's group that just to be sure. And those are the little details I want you to take advantage of when you script. Okay, now it looks like we just have a lot of big numbers here, but really it's not too much. It's 11,240 squared plus 4630 squared. And so I'm kind of going to go ahead and eyeball what this answer is looking like at this point. It's really a big answer for problem 89. And I noticed that in the book, it shows the common denominator as 877. And I'm looking at to see if I've got the correct Z1 and Z2. And I've got the correct Z1. Okay, that checks. And 20 minus 10i, I got the correct Z2. And now the question is the form in the book, and let me write down what the form in the book was. Okay, the answer supplied was going to be 11,240 over 877 as the real part, plus 4630 over 877i. The question is, do I have that? That is the question at hand. Now, I notice I have the beautiful components here, if you see that part here. And so the question is, does this amount here equal 800, 1 over 877? Because I could factor that out. And I think if you go ahead and kind of fiddle around with this, you might find that it is. And if I do that, if I go back and I try to see where this number came from, where 11240 is and where's 4630, where that came from, we might find it. But for the sake of brevity here in this problem, I want you to sometimes look at what's going on in your math, definitely, but I think it's important to see, are we in the right track? Do we understand how to put together the problem of what we're working on? And if we do, then we're happy. So I'm just going to use my calculator now to see if I go ahead and I put 337 times times 500, and I divide that by 11240 squared plus 4630 squared, I get 0.00114, and if I take 1 divided by 877, I do get the same answer. So the two forms, the one I got here and the one in the textbook, give you the same answer. So I think we did that problem right. So we'll stop it and we'll call it a day. Thanks a lot.